Hi guys, in this video we're going to keep working with solving equations. We're going to focus today on some logarithmic equations. So don't forget we have a lot of log properties we can use, such as condensing, expanding, etc. And so we're going to utilize that. Typically when we're solving we are going to want to condense so that we have less log terms to work with. So I want to be really clear, this is probably the most common mistake in solving log equations. So we see log base 4 and we want to apply its inverse, which is an exponential base 4. So I see students do this all the time, and this is not a reasonable thing. The reason is because I'm only allowed to do the same thing to both sides one time each. So for example, this is not raising the left side to a power of 4. This would be, right? Is making that whole thing my exponent. But unfortunately, when there's subtraction in there, these don't cancel across subtraction. So I cannot raise it to the power of 4 yet. So be careful about that. That's probably the most common mistake we see when solving log equations is we automatically try and undo logs when there's multiple. I need to condense it first, and then I can apply that exponential that'll undo it. So this is subtraction. We know subtraction condenses to division. So I still have log base 4. Then the first term is my numerator, and the second one is my denominator. Okay, now that I have one log, now I can apply that exponential of base 4 to both sides. So now one's my exponent over here, this is my exponent over here. Those cancel, so this is no longer an exponent. So we have 100 over x plus 1, 4 to the first equals 4. Now I'm going to solve this for x. So I'm going to multiply both sides by x plus 1 to get that out of the fraction. And I have 100 equals 4x plus 4. I'm going to subtract 4. We get 96 equals 4x. Divide by 4. And we get x equals 24. Okay. My note up here, you guys, this is just a reminder. I would encourage you to write this down as well to check for extraneous solutions. You cannot take the log of 0 or a negative number. So here, if I were to plug 24 back in right here for x, we'd be good because I'd be taking the log of something positive. Really good idea to check with log equations that your final answer, especially if you get something negative, if you plug it back in, do you end up taking the log of a negative? If so, it's not a solution. Okay, this next one. Okay, so I'm actually going to pull this 4 down in front, and the reason is because 4 goes into 8, and it's easier to divide by 4 than taking the fourth root a lot of times. So I'm going to pull that 4 down in front, and we have now, I can divide by 4 to get the log expression by itself. So we got log base 5 of x equals 2. Now, to get rid of log base 5, we're going to apply an exponential of base 5 to both sides. Those will cancel here on the left, and we're left with x equals 5 squared. So x is 25. Again, if we were to put 25 back in there, it's positive when we're taking logs, so we are good. Okay, this next one. It's very similar to the first one. I need to condense this first so I have just one log expression. So I have addition, that's going to condense into multiplication. So I've got x minus 1 times 3x minus 1. So I'm going to go ahead and distribute this. Well, actually, let's go ahead and get rid of the log first. So now that I have one log term, I'm going to apply that exponential of base 4. So now I am going to distribute over here to solve. 4 squared is 16. Okay, so I'm going to distribute. So I've got 3x squared minus x minus 3x, and then negative 1 times negative 1 is positive 1. Okay, I can see I have a quadratic, so I'm going to go ahead and set it equal to 0. So I'm going to subtract 16 from both sides and combine my x's there. So I've got 3x squared minus 4x minus 15. Okay, all right, I'm going to use reduce and bottoms up here because I have a leading term that's not 1. So I've got x squared, 3 times negative 15 is negative 45. Okay, numbers that multiply to be negative 45 that add to be negative 4 would be negative 9 and 5. Reduce and bottoms up, so now come through and divide by 3. Reduces to x minus 3. This doesn't reduce, so bottoms up. All right, set each of these equal to 0. So we got x minus 3 equals 0, 3x plus 5 equals 0, solve, we get x is 3. Here, I'd subtract 5 and divide by 3, so I get negative 5/3. Okay, so I do have a negative solution, so let's see if that is viable. So if I were to plug in 3 back in my original, 3 minus 1 is 2, we're still positive. 3 here, 9 minus 1 is 8, we're still positive. Negative 5/3. If I plug in negative 5/3 right here, I get negative 5/3 minus 1, which is still a negative value. Remember, we cannot take the log of anything negative or 0, so this one is extraneous, which means x equals 3 is my only solution. If you were to list both of these on a quiz or test, you would get some points wrong because this is not a solution. It does not work for the domain of a log function. Okay, that is it for this video. Thanks for watching.